Welcome for those of you that are watching this back to the RIEEE webinar series. Today we're going to hear about the HiveTracks program or the platform. And once we get through the presentation, we will stop the recording so that we can have an informal Q&A and discussion. And then that will be available on our YouTube channel later. So I'll go ahead and turn it over to my colleague, Lauren Essick, who's Research Development and Program our Operations Manager here in RIEEE for a couple of quick logistical details.
Thanks, Grace. So as we said, the webinar is being recorded and it will be uploaded to our YouTube channel sometime in the next week. Grace is dropping that RIEEE YouTube channel link in for us. And we also invite you to hear from us directly by joining our RIEEE Google group. And we're dropping in a form, so you can complete that form to help us follow up effectively to your feedback to this webinar. And I'll introduce our speakers. We have Dr. James Wilkes. James is a beekeeper, college professor, farmer, and entrepreneur with a career in computer science education and research at Appalachian and years of practical beekeeping experience that includes building a small family farm and bee business. His expertise is working at the intersection of computing and honeybees. He creates technology solutions that deliver a positive impact for honeybees and the stakeholders and the food systems that depend on them. James enjoys engaging with the beekeeping community to improve our understanding and care of honeybees. We also have Max Rünzel. Max joined HiveTracks following his appointment with the Food and Agriculture Organization of the United Nations, where he first worked on technology adoption of smallholder producers and later focused on the impact and opportunities of distributed ledger technology in the development sector across the cocoa and coffee value chains. Before working for the UN, Max obtained his Master in Rural Development from a joint European program offered by Ghent University and Humboldt University, among others, and his degree in Food and Resource Economics from the Korea University in Seoul, Republic of Korea. Being fluent in 6 languages and having lived on 3 continents, Max believes in truly global solutions to improving bee health. All right. Dr. Wilkes, if you'd like to start.
Yeah. Max has the slide deck, so I think he's going to share it there and go ahead and get us started, Max.
Yeah, welcome everybody, and thanks again so much, Lauren and Grace, for making this possible. We're incredibly excited to be sharing more about HiveTracks today, about how we're working to unlock the value of nature data by creating a scalable solution that addresses the urgent need for biodiversity monitoring. And it's going to be really interesting. We want this to be as interactive as possible, so feel free, if there's any questions that come up throughout, just to drop them in the chat. And we have a little bit of a structure. So we just talked about who we are, so James's background and myself. James will get us started, and James will talk about the origin of HiveTracks. We can almost divide that up into what happens inside the hive, with a focus more of beekeeping and bee health, and how the transition from beekeeping and bee health went more toward the biodiversity monitoring and the different use cases that I will explain a little bit more about. And we want this to be interactive. We view ourselves as an enabler, as a tool that allows for the collection of data, that allows us to ask new background and ask new and better questions. And we are quite excited for spurring the discussion a little bit and see where this could go. And with that said, I would say over to you, James.
Okay. Thanks, Max. And thanks everybody for being here at the webinar. I've got my class here. We're actually talking about HiveTracks and Bee Informed Partnership, which is Bee Informed Partnership is my academic side of beekeeping. That it was a funding stream. It lasted about 10 years here at App State, and it kind of grew out some of my interests with bees and the HiveTracks development. Bee Informed Partnership was an outgrowth of that. It was about Our funding here was well over $1 million through those channels. The main funding was USDA NEPA program. So again, there's been a lot of good work that's come out of that. You may be familiar with Ramon Kashipuri's work with bees as well, and that was sort of a side effect of some of this. And all that really started with my own sort of beekeeping experience. I moved to a farm over in Ashe County in 2005 and kind of escalated my beekeeping operation there. And then really HiveTracks was born in an aha moment. The picture here of the blue sky, that's at my farm. That's where the ideas for using technology to assist beekeepers to be better beekeepers and have better bee health. So that was kind of the vision from the beginning, and I've been iterating on that since 2010 when we first released HiveTracks. So what I want to give you is just a brief snapshot into why honeybees and honeybee data, or a way in which that data can tell us about what's going on in the environment around a beehive, based on what happens inside the hive. And so going to the next slide there, Max. The most common thing that people think about when they think about honeybees is honey. And honey actually reflects the ecosystem around a beehive. A colony of bees is 100% dependent on what's happening in the land around that beehive, where the bees are foraging. They are sampling the environment, if you will, millions of times. And one of the outputs of that sampling is honey itself. And the nectar from a flower is what produces honey. So the flowers that are blooming in an area are represented in the honey. And they're actually represented by the pollen, not the nectar. The pollen sort of tags along for the ride, if you will, when honey is being made. But you can tell what is being foraged by the bees by what's in the honey. And honeybees themselves, as I said, I've been keeping bees, here for 20 some years. And our particular area is famous for a particular type of honey called sourwood honey. I don't know if that's the next slide or not, but we'll get to that in a moment. And so it's a great proof of concept and use case that illustrates kind of what's going on with the honeybees. You might recognize, well, the flower here is a sourwood bloom. Sourwood trees, it's a tree that grows in the forest around here, kind of just east of us. These green lines, the top green line actually kind of traces the Blue Ridge Parkway. So a good visual for us here is if you're on the parkway and you're looking out over the forest, that's a great area for a high density of sourwood trees. So when the sourwood trees are blooming, there's a high density of nectar for the sourwood. We put bees in those locations so that they collect that sourwood nectar during that time window. And then that determines the honey that we get off of those hives. And the sourwood honey is world famous. It wins world honey competitions. It has a very unique flavor profile, and it's really made just here, nowhere else in the world. Again, so it's a great example to illustrate how the bees are showing us what's in the area around the hives. And we're, as Max will talk about in a little while, kind of how we're leveraging that behavior, natural behavior of the bees and the beekeepers. The beekeepers are observers in these systems as well. And so whenever they're going out, they're taking observations about what's going on, both inside the hive and outside the hive. So let's go to the next one, Max. And the other thing that influences the honey that's collected and the health of the bees is time and place, time of year. Honeybees operate kind of seasonal. It's an agriculture sort of biological system that the bees are part of. And so they go through cycles during the year. There are different kind of bee health issues that we have at different times of year, depending on what's blooming, how good the weather is or bad the weather is, significant weather events. All these things influence the productivity of the hive and the health of the hive. And the app that we have, you see some screenshots here. This is from the HiveTracks mobile app. The way it's used by beekeepers is when we go out into the field to go to visit our hives, that's kind of the normal cycle or process for beekeepers. We take notes, we take images, we record the observations that we have about the bee health. And so we are able to track that data. That's why it's HiveTracks, right? So, that's what the app does and facilitates the beekeeper in collecting that sort of data. All right, next. So again, if we'll focus in just a little bit on this sourwood nectar flow. These are some examples of things that we as beekeepers observe. And if you want to nerd out a little bit on kind of IoT devices, sensors in hives, the graph there is a typical graph of weight versus time. So on the left-hand side scale is the weight of a hive, and across the bottom is time. This is the sawtooth figure profile that you get is typical of a nectar flow or a honey flow, as we call it. And it shows each day the bees coming in, bringing in a lot of nectar. Then at night, they actually dry that nectar out, turning it into honey. And then that repeats. And of course, if you bring in more nectar than you eat or consume, then that scale is going to go up. So this is a place where technology has helped us kind of look in and see what's going on inside the hive. All right. So again, in these areas that we're in, the sourwood tree is more prolific. There's a little bit of interesting history. Those areas that I showed you on the map have been heavily logged historically, and the loggers typically don't take the sourwood trees. They're not good for lumber. They're kind of crooked. They grow on the edges, and they're kind of ugly trees. And so just because of that, they just left them, and the density is pretty good in this area. And the happy side effect of that is that we get sourwood honey from those trees. But it again demonstrates that we can detect what's going on in this area. All right, Max. So Max is now going to take, again, that was just we could talk forever. We can have our own webinar on bees and how they behave and that sort of thing, and it's very interesting. But so Max is going to take us now. How are we translating this work I've been doing for the last 14 years of assisting beekeepers in keeping healthier bees? How can we leverage that and the information that we're able to get into these other spaces? And so Max is going to talk about that.
Yeah. Thank you, James. And this is sort of how James and I met. About it's 5 years ago now. I was working in Rome, Italy, at the UN. I had maybe heard of North Carolina, but certainly not heard of Boone before. Coming from Germany originally, and this was the natural progression of understanding. I mean, you've heard some of these terms to bees thrive if there's a lot of different flows, if there's blooming periods that happen concurrently or one after the other. So we started to understand and look more and more how bees, sort of as biosensors, as canary in the coal mine, actually can be a good idea to look at something that we knew was a risk for some time, but it's getting more and more attention now, which is sort of the biodiversity decline that we're seeing, in terms of understanding that sustainability, if you will, is an equation that depends upon climate and nature, right? And a lot of focus has been on climate over the last 15 to 20 years. And now nature is catching up, that people are understanding you can actually be climate positive while being nature negative. And the interesting aspect with biodiversity is, as biodiversity is at risk, it challenges the ways that we produce food, generate energy, construct buildings, and even access nature. There are so many use cases, and this is what we will be talking about a little bit more, where we are just scratching the surface and understanding what does biodiversity have to do with how nutritious the food is that is being grown? What does biodiversity to do with mental health applications? There are so many components of biodiversity, and this is particularly interesting living in an area where the biodiversity is so high. Being in the Appalachians and being in the Blue Ridge Mountains, some of these questions are particularly interesting because we don't see at times how different biodiversity is because we're basically used to a high biodiversity area. But in a sense, the way we produce food, so our agri-food systems are responsible for 90% of land use change, and 86% of the threatened species are a direct result from the way that we conduct agriculture and produce food. The next big culprit is the built environment. So anything we do in terms of energy generation, the way we construct our roads, our homes, has a direct impact on land use and land cover change and biodiversity loss in particular. And now the question becomes, what if we could work with organizations to help them understand their nature-related risks like drought, flood, wildfire, and turn biodiversity into a mainstream metric, right? So something that we're working toward, and our big vision is to say, is there a data point for environmental health, for biodiversity, that would become a standard measurement that is considered within any construction project, within any engagement of any organization on the way that an organization or we humans impact nature and how nature impacts what we do. And this, of course, to be able to work with organizations and to understand how nature impacts what we do and what we live, we have to start to get a better understanding around how we can capture data continuously on changes in the environment. And the interesting aspect there is that many of the capabilities that we currently have are either not granular or frequent enough or don't scale very well because they're very expensive. Much of the remote sensing technology, such as drones and satellites, are being used, but if you think of it or look at Google Maps, it's almost impossible to take a picture of a bee or of a flower using a satellite or a drone because the resolution is not there, or you would have the cloud coverage. Desktop analysis is being used using data sets that are freely available on the internet, but they also usually summarize it up on a very, very high level. Trained ecologists is sort of the go-to means that has been used in research for the last 50, 60 years. That, of course, often just gives point-in-time assessments. It's also very, very expensive. And some of the newer ways of like lab and eDNA analysis are interesting and give a more of a structural biodiversity assessment, but are also costly and oftentimes don't contain the timely component of it. And so looking at how much biodiversity is at risk and seeing kind of the limitations of the monitoring technologies, we started to look into and understand, okay, what would happen if we actually worked with our beekeeper community that goes to the same spot every week to understand how nature changes over time. And there's a couple things that made this possible. One is in a large user base that uses a mobile app. So it's an app that contains a camera that is getting better and better. So the mobile phone cameras now, compared to 5 or 6 years ago, allow for an analysis. And more recently, the enablement through large language models that allow for both image recognition applications and then characteristic applications to better understand what happens at any given spot, and above all, what happens over time. So as James was saying, to look at the tool of biodiversity monitoring, we had always been looking at how healthy a hive is. This is sort of the inside the hive piece. How do we assess the health of a hive? How productive is the hive? Does the hive get through winter? Those have always been the most interesting questions. And we've also started to look at, as James was saying, when you look at how much honey is being produced, how much nectar is being collected, and you know the weather conditions for a given spot, you can also understand what the pollination events are in a given area. Now, what we've started this year is to expand into floral diversity and abundance, so understanding anything that blooms in the surroundings of a particular apiary, and followed by native pollinators. So anything that has to do with insects that not necessarily have to be honeybees. It could be moths, wasps, flies or bumblebees, anything that are not managed pollinators, to get a better understanding of the plant pollinator-derived biodiversity, which is one of the key aspects for ecosystem service delivery within any terrestrial ecosystem. It really, on the other end of like germination is the pollination part, and that is something that can be assessed. And the next step that we took from there is to say, okay, what happens when we start looking at monitoring biodiversity even beyond a beehive? So, what we did earlier or mid this year is we launched the ability to monitor nature, monitor biodiversity, regardless of a hive that is being positioned in a particular place, which really allows to understand over time how biodiversity shifts and what the specific impacts can do. And then again, using the LLMs and the technology to have the quality, the QA, the quality assurance and the quality controls to be able to generate decision grade output from the data collected. And this is now how we work with different organizations across different places, where we have small projects where we work with a beekeeper or a data collector in any given area to start understanding what an organization's operational risk could be, from degrading habitats or soil erosion, flood or wildfire risk. This is an example of one of the sites that we have in Germany, and to start to understand how can we influence policy making, for example, as we can really monitor and manage nature impact over time. That allows organizations to better understand how either the landscaping or the lack thereof should change over time, in particular vis-a-vis a more changing climate, right? Where sometimes the planting recommendations or the flowering recommendations from 20 years ago are no longer valid. So understanding the larger trends of how biodiversity shifts in a given space. And this also further allows the ability, as James was just seeing with the IoT graph that we had, to and go a little bit deeper and perform lab tests on the pollen to understand, kind of get the lab results from what the pictures represent, or sensors that give a more granular assessment around the nectar being collected. And now here's what we're right now in the middle of doing, is looking at working in specific projects and in specific areas to start to understand what the biodiversity in given areas are and how biodiversity affects the environmental health in these areas. And this, for example, here, these are a few projects that we are doing in Kentucky at the moment, which show with each of these dots actually what was blooming at what point in time, understanding how that shifts over time throughout the season, but also then now in the next step start to understand what is the health of these particular plants, how many of those are native, how many of those are invasive, what does that mean for the soil conditions, what is the water use efficiency of each of these, of a zigzag spiderwort, for example, or American pokeweed, to start to understand what is the biomass that is being generated over time. And this is so each of these little dots that you see is one particular, each color is one particular species that we have and how they overlay in given areas. Here is another one, how you can see that, there's certain types of plants that you would see in certain types of areas in particular that cluster together and that then change over time. So this is one of the case studies that we did for the Cherokee part, where we detected 54 unique plant species, and we saw that 37.73% are flowering plants. So this allows us now to start understanding what is the level of pollinator attraction, for example, what is the percentage of invasive versus native, how are we looking in terms of temperature or drought tolerance or water efficiency, what is the cold hardiness, and all of this even being done with a methodology that allows to weekly survey a subset of the overall area, identifying the different species either in the plant or the pollinator, using our tool, and then also performing pollinator counts that allow not just to look at the diversity, but also the abundance, right? So looking at diversity of plants, for example, or pollinators, but also the abundance, which either means in a time constraint or in a space constrained area, which could be a quadrant in this case. And then in here you can see, looking at, from anything from the flora composition, the species richness, fauna diversity, and from inputs to insights. So this is coming to the end of the presentation and opening up for the questions. This is essentially our ask to spur this discussion, is to understand what are the exciting questions that we could ask when we start to have ground truth biodiversity data continuously collected. What does that mean for looking at biodiversity in a scenario that could either be on campus as at a building at Appalachian State, to start to understand questions around how a construction procedure, for example, disrupts or changes the way that biodiversity, that either the environmental or the biodiversity increases or decreases. And then also starting to understand, because of the way that the data is being collected with a community focus, what applications there are to engage students and engage communities in a new way, right? Really, so using this community-based sourcing of environmental data in a very in a small area that allows us to track it over time and start to make better decisions that allow us to either, for example, reduce the water use, plant more native plants, reduce the maintenance cost of it, or to embark on very exploratory research that could look into new connections around what other areas of our lives are impacted by an increase or decrease in biodiversity.
Thank you, Max and James. I'm going to thank the people that are here live and anyone that might be watching this back, and invite Lauren to stop the recording before we go into Q&A.